We're going to continue with chi-square testing, but this time we're going to specifically be looking for the expected values. Those expected values are the values that we use to compare to the observed, the data that we have from our sample, in order to calculate the chi-square measure. Now, we've had the calculator or the online calculator compute those chi-squared values for us, but we also want to be able to come up with our expected values. I'm going to be using this first website to get those expected values as well as the calculator. I want to start with example number 2. So let me scroll down to number 2 here. We've got a group of 120 people that were asked which type of coffee they preferred. Is there a relationship between age group and coffee? Does the age group that you're in affect which coffee you prefer? We're going to test this at the 0.01 significance level. Actually, what we're going to do is come up with our expected values. So the first thing that we notice is that we've got 120 total people. So if we add up the 23, the 7, the 12, and the 38, all of these values, and I'm going to put my n down here, are going to add up to 120. I can also go ahead and add up the rows going across. So I get 30 in the 16 to 35-year-old group. I've got 50 in the 36 to 55-year-old group. And then finally, I've got 40 in the 56 to 75-year-old group. I add those up and I get 120. I can do the same thing adding down. So of the people that we surveyed, the people that preferred Dutch Brothers were 23 plus 12 plus 5. Let's see, that would be 40. Just adding those up. And all the people that preferred Starbucks, that's going to be 7 plus 38, that's 45, plus 35 is 80. And you'll notice that these also sum up to 120. What we want to do when we're finding our expected values is to pull all of this together as if it doesn't matter. So regardless of age group, we've got, for the Dutch Brothers, we've got 40 people out of 120, and if I put that into my calculator, 40 divided by 120, we have 33.3% of this group. So 33.3% of the total preferred Dutch Bros. So 33.3%. So the other 2/3 must prefer Starbucks. So if I do 80 divided by 120 out of my entire group, 80, there we go. Okay, so 80 divided by 120 of our entire group, 2/3, or 66.7%. So 80 out of 120, or 66.7%, prefer Starbucks. When I'm looking for my expected values, I assume that everybody's in the same group and that age group does not affect which coffee you prefer. So I'm just going to assume out of each of my age groups, 33.3% of them prefer Dutch Bros and the other 66.7% prefer Starbucks. So I'm going to recalculate each of these. And I'm going to go ahead and start with the Dutch Bros. I'm going to use 33.3% for all of my Dutch Bros calculations. So the first one would be, so I'm just going to put a little star here. Let me change this to blue. So as I'm calculating this, put a little star here. I'll do 1. Okay, so as I'm doing number 1, to refill that one in as if age group didn't matter, I just want 33.3%, so 0.333, times the entire group is going to be in that Dutch Bros family. So that's going to be 0.333 times 30. So 9.99, we could write that as 9.99, or we could round that to 10. I'm going to go ahead and round it in this one to 10. So 10 is my expected value. And as I'm filling in number 2 here, so number 2, that would be 0.667 times the 30. Well, it's got to be the other 20, right? If I do that over here, 667, or you could put a whole bunch of 6s, right? 7 times my 30. It's got to be the rest of them, right? That's going to be 20 of them. And then we can continue to redistribute based on my overall percentages. So as I move on to cell number 3 here, cell number 3 is going to be 33.3% times 50. And I can do that in my calculator. I can just put a bunch of 3s there, times 50. And that's going to be 16.66665. Let's just round to one decimal place here. I'll call that 16.7. So 16.7. The rest must be in the Starbucks group. So we're going to go point, and we'll just put a bunch of 6s there like we did in the last one, 7 times, and this is my group of 50, 33.3. 33.3. And you know you're on the right track because when you add 16.7 plus 33.3, they still add to 50. I'm just redistributing based on these overall percentages. I've got one group left to go. So let's go ahead and do the final age group. There are 40 of them. So if all things were considered equal, a third of them would be in the Dutch Bros group. So point, and then I'll just do a bunch of 3s here. Times, that's my group of 40. I'm using this 40 right here, times 40. Enter. That's 13 point, we'll call that 13.3. The rest of them are going to be in the Starbucks group. So point, and then we'll just do a bunch of 6s times 40. And we get 26.7. So 26.7. I can add all of these up and confirm that I've just redistributed each of those groups. What I've got in blue are my expected values. And my expected values come from my null hypothesis saying that chi-square is equal to 0. There is no significant difference, or there's no significant relationship between age and coffee preference. You're just going to follow what the overall group does. So that's where our expected values come from. Now I've done all this by hand, which is a lot of work. I can also just have my calculator do it for me. So I'm going to go to second and then matrix. And I want to edit a matrix, so over to edit. This one has 3 rows and 2 columns. I'm going to put in the observed values, so that's 23, 7, 12, 38, 5, and 35. And then I'm going to run my chi-square test. So I'm just going to double check my values there. That looks good. Okay, so I'm just going to run my chi-square test. So second and then stat. Over to math. Chi-square is towards the bottom, so I'm going to arrow up. Oh, whoops. It's not second stat. I just want stat. There we go. Arrow over and now up to my chi-square test. Enter. And notice how the observed values are in A, which is where I put them, but it's also just going to throw my expected values into B. It's going to do those calculations that I've done. So that sounds great. I'm going to go ahead and hit calculate. Very small p-value, right? So I know that I would end up rejecting this hypothesis, but I'm not going to run the hypothesis. I just want my expected values. So I'm going to go back to my matrix menu. Let's take a look at matrix B. Notice how it's now a 3x2 matrix. The calculator has overwritten the expected values in there. I'm just going to leave myself on names, and then I'm going to choose B and then hit enter. It's going to throw B into my home screen, and here it is. I get 10 and 20. Take a look at these expected values, 10 and 20, 16.7, 33.7, 13.3, and 26.7. Really great news, right? I don't have to do all of the calculations. So the calculator does a really nice job with this. I also want to put this into my, my online site. So let me go ahead and grab it here. I'm going to pull it off so that it's in its own screen. And we'll do it like that. Okay, so what I want to do is I'm doing this with my online site. I want to go ahead and type in, not these values, just going to backspace over those. I'm going to go ahead and type in my values, and it prompts you to put them in with a comma. So 23, comma 7 is row 1. I'll hit enter then. 12, comma 38, enter. And then 5, comma 35. This is also a great way to run the hypothesis test. I'm going to go ahead and hit run. And then as I arrow down, it gives me, there are my expected values, and it also gives me the chi-square and that same p-value that we found, which is really, really small. So we know either based on that large chi-square value or that very small p-value that we would reject this null hypothesis for this particular test. Okay, let's go ahead and run through the others. Let's see, for number 1, let's go ahead and do this one first with the calculator. So I'm going to go ahead and grab my calculator, clear this, and I'm just going to start by entering this into my calculator. I want just the expected values here. Let's say I do need to edit matrix A. So edit. This time it has 2 rows and 4 columns. Okay, and my values are 9, 5, 7, 6. And then my second row is 19, 10, 17, and 12. 9, 5, 7, 6, 19, 10, 17, 12 looks good. So now I'm ready to quit here. I'm going to go into stat and then run my test, which will calculate those expected values. And I want that chi-square test. My observed, I did put into matrix A. It's going to throw those expected values into matrix B. I hit calculate. We're not going to worry about all of the test values that we get. I just want to look at matrix B. So I'm going to go second matrix. Notice how B is now also a 2x4. Just staying in the names or the names menu, I'm just going to hit enter for B and then hit enter, and it gives me my expected values. So you just really want to know when you're writing these, make sure that you're rounding them to whatever values they're asking. I'm going to round these to 1 decimal place, 8.9, 4.7. Let me go ahead and grab the second row before I scroll over, 19.1, 10.2. And if I scroll over, notice there's a little arrow right here. It's really hard to see, but it says that you can use this arrow here to see the others. So then I get 7.6, 16.4, and then finally 5.7, and 12 point, if I round to 1 decimal place, it's going to round to 12.3. So I've got my expected values there. Let's recalculate these using our online site. So I'm going to just highlight and clear what I had there before, and let's go ahead and type in these rows. So I've got 9, 5, 7, 6. This is such a nice program. 19, 10, 17, 12. Okay, so it's really easy to enter those data. I'm going to go ahead and hit run. It's going to return everything I need, including my expected values. And you can run through and see that your expected values here do match, although I rounded to 1 decimal place. They do match what we came up with. We also have this huge p-value. That huge p-value tells me that I'm going to fail to reject. One of the things that clues you in is the difference between your expected values and your observed values. So observed is in black, expected is what we just calculated, 9 versus 8.9. Remember that chi-square is a difference, observed minus expected squared, which you didn't have to calculate, but it is a difference between the observed and expected values. As you look at the observed values that we were given and the expected values that we computed, they're really, really close together, which explains this chi-square value that we got, which is very small at 0.11. So we know based on the small chi-square, based on that really large p-value, that area of the tail cut off by this statistic, that we would fail to reject. Let's do another example here. Just to get a little more experience in, we'll just do number 3. Okay, number 3 is a nice small one. I'm here in my online calculator for chi-square. Let's go ahead and do it here. So I've got 32, 18 for the first row. Second row is 39, 21. I'm going to go ahead and run this. Again, it gives me everything I need. I don't need to put this into the calculator. So I've got all of my values here. If I round those to a single decimal place, I would go ahead and put in, let's see if I can see these both at the same time. Make this a tiny bit smaller so I can see. There we go. Okay, so we get 32.3 if I round. So 32.3. I'm choosing one decimal place just because it fits. So 17.7. So if you're working some problems, just make sure you read the instructions. 38.7 and then 21.3, 21.3. Let's go ahead and do this with a calculator and make sure we get the same answers. I'm going to go into my matrix menu. So second matrix, I want to edit that matrix A, enter. This time it's a 2 by 2. My observed values were 32, 18, 39, and 21. I'm going to go back to my home screen, second quit, and then into my stat menu, over to tests, arrow up to find that chi-square test. It's going to throw the expected values into matrix B. So I go ahead and calculate, and let's take a look at matrix B. So second matrix, B is now a 2 by 2. Great. And as I take a look at that, I do get the same values rounded to one decimal place. So both of these methods work great. Both of the methods give you all of the information that you need. Just make sure that as you are working problems that you're looking to see how many decimals you should be rounding those values to.